All right, guys, so we are going to be taking notes on page 28 of your Ready workbook. And so last time we talked about translations, we talked about reflections. So today we need to talk about rotations. So we are going to be rotating 90 degrees counterclockwise to get our image P prime, Q prime, R prime. So just a quick reminder, clockwise is the way that a clock goes. So clockwise is this direction. And I call that CW for short. Counterclockwise, which is the one that we're going to be going, I wrote counterwise, counterclockwise, which is the way we're going to be going, I call that CCW. That's the opposite direction. So that's going in the exact opposite of the way a clock goes. So 90 degrees is a right angle. So if you think of each quadrant as a right angle, if I'm going 90 degrees counterclockwise, I'm only going one quadrant away from where I'm started, and I'm going backwards from the way my clock goes. So it's good to know where your answer should end up based off of this so that you can kind of have a good idea if your answer looks correct or not. So at the bottom, they actually show that twisting action. So 90 degrees is a quarter of 360, so it's only 1/4 of a full turn. And so each angle is going to make, or each vertex is going to make a right angle with the origin. So Q, we could draw a right angle, that's where Q prime ends up, and R, we could draw a right angle, that's where R prime ends up. So it's kind of cool how that works. Okay, so one quick note that I would like you to write down is that 90 degrees is, if we go 90 degrees counterclockwise, which we are in this graph, so we're going 1/4 in this direction, that's actually the same as going 1, 2, 3/4 in the other direction, which would be 270 degrees. So 90 degrees counterclockwise is actually the same as going 270 in the opposite direction. And the same is true if we were to go 90 degrees clockwise, that would be the same exact thing as going 270 degrees counterclockwise. So just keep in mind that these movements are all equal to each other. So let's now try to come up with a rule, because we want a rule that is going to help us easily determine the coordinates of our image when we rotate it. So at the bottom here, we're using the graph above to come up with the coordinates. So P prime was at 1, 1. If you look at new Q, Q prime, it's at 2, 3. And if we see R prime, it's at 4, 2. So we're looking for the connection between the pre-image and the image. Pre-image, image, pre-image, image. So let's flip over to page 29 and come up with the actual rule for each of these. So table in question 2, the table in question 2 has a pre-image and an image. And this is when we go 90 degrees, sorry about that, 90 degrees counterclockwise. So let's see, can we see the connection between the pre-image and the image? So I started at 2, 1, and I ended up at -1, 2. So far I'm noticing the numbers are similar. -1, 3 ended up at -3, -1. -4, -2 ended up at +2, -4. And 6, -5 ended up at 5, +6. So I'm not sure if you're noticing this, but essentially what happens with 90 degrees counterclockwise is we are going to switch X and Y. So the X and Y coordinates flopped, but we also, notice how it wasn't just that they switched. When the 1 came to the X coordinate, it became -1. Same thing here. When these switched, -1 stayed the same, but 3 became -3. When these guys switched, -2 turned positive, and when these switched, -5 became positive. So we're going to switch x and y, and then when we get our new x, so we're going to make the new x coordinate opposite. So if it was positive, turn it negative. If it was negative, turn it positive. So let's extend this out and just do one more example. Let's see if you can do it on your own. What if I had 2, -3? So follow the rule, switch x and y, make new x opposite. So the new x is going to be -3. So to make that opposite, it's +3. And then I won't change y. I'll keep y as 2. So I swapped them and made the new x coordinate opposite of what it was. If we look at the next table, this one is going 90 degrees clockwise. So it's going the other direction. 2, 1 became 1, -2. -1, 3 became 3, 1. -4, -2 became -2, 4. 6, -5 became -5, 6. So this time you're probably catching on to it quicker. They are switching. This time, y is what's becoming opposite. So they swapped -1 and 3. 3 stayed the same, but y became +1. They switched -4 and -2. -2 stayed the same, but it became the opposite, +4. 6, -5, switched and became -5, -6. So our rule here with 90 degrees clockwise is still to switch x and y, but you're going to make new y coordinate opposite. So when you're doing your homework with this on IXL, have these rules written down somewhere or have page 29 open so that you can be seeing your two rules for 90 degrees clockwise and 90 degrees counterclockwise. And I'm noticing here it says counterclockwise, but I think in your book it says clockwise. And we're going to skip 4 and 5 on this page. So you can just cross those out and let's move ahead to page 30. So on page 30, Carter is rotating the image 90 degrees clockwise. So just for us to help us with this problem, let's write down the 90 degrees clockwise rule. So the rule is switch x and y, and we're going to make new y opposite. Okay, so to do this, I would like for you to first start by writing down the coordinates of the pre-image. So we're going to make a table, just like we had on the last page. We're going to have the coordinates for j. The coordinates for j are -4, 1. We need the coordinates for k, -4, 4. We need the coordinates for L, -2, 6. And we need the coordinates for M, -1, 5. Okay, so J prime, new J, is going to switch X and Y and make the new Y opposite. So 1 stays the same, -4 becomes opposite, +4. Switch X and Y, new X stays the same, new Y is opposite, so +4. Switch X and Y, new Y becomes opposite, so it's +2. Switch X and Y, oops, sorry, these should be prime. Switch X and Y, make new Y opposite. And this is great because if I'm going clockwise, the clock goes this way, I'm going 1/4, 1 quadrant to the right. All of these are positive, that's great. Every coordinate in this quadrant is positive. So let's plot the points. So J is 1, 4, so I'm going to label that J prime. K is 4, 4, K prime. L prime is 6, 2. M prime is 5, 1. And so J and K connect, K and L, M and L, J and M. This is good because a rotation spins the shape. So our shape, which had like this line facing upwards, now it's facing sideways. So it went from being vertical to horizontal. These two diagonal lines are diagonal but facing downwards. And then this line kind of twisted downwards that way. So that is the right shape. It's a good spin. So now they have a 180-degree rotation. For 180 degrees, this is a new rule. So again, when you're doing your homework, you probably want to have this rule written down. The rule for 180 is pretty straightforward. It's just make X and Y opposite. So there's no switching, because if you think about it, a 180 degree, and you don't have to write this down, I'm going to do this in blue. 180 is a 90 degree plus a 90 degree. So let's say I start with XY and I go 90 degree clockwise once. I'm going to switch X and Y and make Y, the new Y opposite. So I would switch them and make the new Y opposite. Then when I did another 90 degrees, I would switch them again and make the new Y opposite. So the double switch gets me back to my original, but both coordinates would have to become opposite because of that like make opposite part of the 90-degree rotation. So we're going to do the same thing. I don't have as much space as you guys do for A. So I'm going to do my work for A right down here. You should be writing all of your coordinates of the pre-image down. So coordinate A is -4, 3, X first, then Y. B is -2, 5. C is -1, 2. D is -2, 1. So let's apply our new rule for going 180 degrees, and that is to make X and Y opposite. So A prime is going to be +4, -3. B prime is going to be +2, -5. C prime is going to be +1, -2. D prime, I'm making both those coordinates opposite, +2, -1. And that makes me happy because the X coordinate's positive, the Y coordinate's negative. That's going to bring me to the fourth quadrant, which makes sense because 180 is 1 quarter plus another quarter. So my answer should be in this bottom quadrant for a 180 degree. So let's label them. Let's label A for -3. That's A prime. B is 2, -5, B prime. C prime is 1, -2. D prime is 2, -1. This is awesome. This is exactly what it should look like. My little trapezoid spun around to the fourth quadrant. And question B, again, I'm sorry, my screen doesn't have as much space as yours does. Here's my answer to question B. If I went 180 counterclockwise, so if I went 1 quarter and another quarter, I'd end up in the same place. So 180 degrees clockwise is the same as 180 degrees counterclockwise. And so that's very exciting. We don't have to memorize anything new with that. All right, one last problem. So Diego is going to go 90 degrees counterclockwise. So again, with these problems, write down what the rule is. If you look back to page 29, the rule is switch X and Y. With counterclockwise, you make new X opposite. All right, so let's go coordinate by coordinate. It's kind of nice when they give you the coordinates because you don't have to do the extra work like we did for the actual plotting. So I'm going to switch X and Y to get F prime. And then the new X coordinate needs to be opposite. So it's going to be +3, -1. Make this positive once I switch it. G prime, switch x and y, make new x positive. So it turns to positive 5, negative 3. H prime, switch x and y, make new x positive to negative 5. So when you're coming up with the coordinates in your homework, make sure you're using the rule that matches the type of transformation you're doing. So you should have 3 rules written out for this.